Okay, for number 8, again, we are doing our integration by parts. And so we do want to rewrite this. Now, you don't have to, but a lot of times it's a little easier if you separate these terms into 1 over x squared and then natural log of x. And then whenever we set up our integration by parts, we're going to let u be the natural log of x. A lot of times, that's a good way to start these. And if you don't know, well, start with the natural log of x. And then du is going to be 1 over x dx. And then dv, again, that's going to be 1 over x squared, or x to the negative 2 dx. And so when I integrate that, I'm going to have negative x to the negative 1. So now we're ready to go through our process. So we have uv, so I'm going to have negative 1 over x times natural log of x minus the integral of v du, which is going to be 1 over x dx. All right, so we have negative 1 over x, natural log x, and then I'm going to move that negative out, so plus the integral of 1 over x squared dx. And that is something a lot easier to integrate there. So, again, moving all this stuff down. And we can think of this whole term as x to the negative 2. So if I add 1 and then divide, so I'm really going to have negative 1 over x. And then we have plus c. And we can go ahead, and a lot of times you're going to just see this, since both negative 1 over x is in both terms, you could see that factored out. If we do that, that's going to leave us with natural log of x plus 1, and then we have plus some constant c. Either one of those would be fine for your answer. Okay, number 9 is another great example of going ahead and letting u be the natural log of x. So we're going to have u as natural log x. So then du is 1 over x dx. And then our dv value here, we're going to let dv is going to be x dx. And so whenever I integrate that, then we're going to have 1/2 x squared. Now we're ready to put these together. So I have uv, so I have the natural log of x times 1/2 x squared minus the integral of 1/2 x squared times du, which is going to be 1 over x dx. And so simplifying here, of course, all of this stuff just moves down. And then 1 over x is going to cancel. And then I'm going to move this 1/2 out. So I'm going to have minus 1/2. And then that's really just the integral of x dx. So then that's going to give us another 1/2 x squared. And then plus c. Okay, this next problem is probably one of the strangest problems you'll see. It's not entirely uncommon to see, but it only pops up every now and then. And with this being cosine squared, you do separate it, and that's what makes this a little bit different. You're going to rewrite cosine squared to be cosine times cosine. So in other words, I'm going to have the integral of cosine theta times cosine theta d theta. And we're going to do our integration by parts this way. So we're going to let u equal one of the cosine thetas. And so then du is going to be negative sine theta d theta. And then, of course, dv, well, that's going to generate, we're going to have to use cosine theta d theta. And if we integrate that, then that's going to give us sine theta. All right, now we're ready to do our process. And so when we start this, we're going to have uv, so I have cosine theta times sine theta minus the integral of v du, which is another negative sine theta d theta. So I would move that negative out. So we have cosine theta sine theta plus the integral, and notice that's going to be sine squared theta d theta, which is really strange because we started with cosine squared. So really right here we have a trig identity that tells us that cosine squared theta plus sine squared theta is 1. And so I'm going to rearrange this and solve for sine squared. So I'm going to subtract our cosine squared over. And this is where we're going to start seeing some strange things happen with this. So again, we're bringing down our cosine theta, sine theta, and then we're going to have plus the integral of 1 minus cosine squared theta d theta. And then here, of course, with our integration, we can separate this and this. And notice that when we do that, we have cosine theta, sine theta, and then plus, if I integrate just 1 with respect to theta, that's just going to be a theta. Think of it just like an x or a y or a z, whichever. And then I'm going to say minus the integral of cosine squared theta, which should be a big oh no, because I already have cosine theta up here. Notice that's what I started with, is what I got here. Now keep in mind, this is all, we can set every bit of this equal to, well, aren't we trying to find the solution for cosine squared theta d theta? So this is where I'm saying it's strange, because we've not seen anything like this just yet, but we're getting there. We're going to treat this just like an equation to solve. So I'm going to add an integral of cosine squared theta d theta to both sides. So that's going to leave me with cosine theta sine theta plus theta. Again, that's coming from integrating just 1 there. And that's going to be equal to 2 times the integral of cosine squared theta d theta, which again is really strange. And then we're going to divide both sides by a 2, and we're going to be finished with this. That's going to cancel out our 2's. And so notice this final answer, and you can leave it all over 2 or put a 1/2 in front, whichever. You're going to have cosine theta sine theta plus theta all over 2, and of course we have a plus c there. And that's going to be equal to, again, what we started with. So that's going to be our final answer here. And this is one of those that you see becomes a repeating process. And so every time you have these in your doing your integration by parts that starts repeating, you'll do something just like this every time. All right, so for this one, and we can choose use substitution, integration by parts. This is pretty much what everything thrown at us at once. So starting out, let's say we're going to have integration by parts. I would let u be sine x. So du is going to be cosine x dx. And then let's see, we're going to have dv, which is going to be e to the negative x dx. And so if I integrate that, then we're going to have negative e to the negative x. And so now we're ready to set up our integration by parts, but it looks like we might end up going in a circle again. Let's see, uv, so we have negative e to the negative x sine x minus the integral of v du. And right away I see that I've generated again what I've started with, so it looks like we're going to have to do our integration by parts again. So here I'm going to say, well, u again is going to give us cosine x, du is going to give us negative sine x dx, and then dv, we're going to make that e to the negative x dx. So v is going to be negative e to the negative x. And so we're moving all this stuff down. We have negative e to the negative x sine x. I am moving that negative out, so that's going to be plus. And then we have uv. So, well, I guess that plus needs to go to a negative, doesn't it? Because uv, so that's going to be e to the negative x cosine x minus the integral of v e to the negative x du, which is going to be negative sine x dx. So again, it looks like we're really going around in a circle here. I'm going to move that negative. Well, those end up being positive. So here we're going to have negative e to the negative x sine x minus e to the negative x cosine x. And so that's going to be minus the integral of e to the negative x sine x dx, which is what we were starting with. Notice that, again, this ended up being exactly what we started with. And so this is where we set that, again, equal to our starting point, which was, again, e to the negative x sine x dx. And I'm going to add this over. So then we're back to negative e to the negative x sine x minus e to the negative x cosine x equals 2 times the integral of e to the negative x sine x. And again, I'll divide both sides by 2 or multiply by a half. Either is fine. And then the rest of this would be trying to find your answer choices. All right. Looking at this one, we could do a u substitution. Let's separate it first, though, and see. I would separate this into 1 over x times 1 over natural log of x all cubed. And I know if I do the derivative of natural log of x, I'm going to get 1 over x. So I would probably just do a u substitution for this one. And then du is going to be 1 over x dx. And again, solving for dx, I would multiply this x over. So I have x times du equals dx. So going back and subbing in our u sub, we're going to do the integral of, we had 1 over x times 1 over natural log, but we're going to say that is u cubed. And then dx we said was x times du. And as those x's do cancel, so I have the integral of u to the negative 3 du. So that worked out good. And so that's going to be u to the negative 2. So divided by negative 2 plus c. And then we do need to go back and substitute in our natural log. So we're going to have negative 1 over 2 times natural log of x, and then plus c. Another strange problem alert. I would just go ahead and start out right here with a square root of x. So let's just let u equal square root of x, or x to the 1/2. So that means du is going to be 1/2 x to the negative 1/2 dx. And if I solve for dx, I'm going to have, let's see, that's really in the denominator, so move it over here. It's going to be positive. So I'm going to have 2x to the 1/2 du is equal to dx. And so whenever I plug in my u substitution, I'm going to have cosine of u. And then in place of dx, I'm going to have 2x to the 1/2 du. Well, that's going to be strange because I've got two different variables here. Normally it cancels out, but I do know x to the 1/2 is u. So really, I could say that I have cosine of u times 2u du. And then definitely move that 2 out because nobody wants to work with that for sure. And I'm going to rearrange these. I'm going to put u on front and then cosine of u. I don't like those u's being side by side. Might be tempted to make that u squared and then all sorts of hell will break loose. All right, so let's see. We can now, let's let u be equal to, goodness, what can we let u be? Well, if we let u be u, then that, we might just go in a circle with that. That's going to be strange. Well, let's give it a try and see. If u is u, then du is going to be, well, we can't do that, can we? We need another variable. Oh my goodness. All right, so let's go change our variable. Oops. We don't want u. So, I don't know. Let's let, we can't do x either, so let's say z. I'm going to let z equal u. So, dz is going to be equal to du. And then if I let v, hey, dv, we haven't used v yet. If we let dv equal cosine of u, du, if I integrate cosine, then I know that v is going to be sine u. All right, I think we might have made some progress here. All right, so uv, so that's going to be u times sine u minus the integral of v du, which is sine u du. All right, so we have u sine u minus the integral of sine is negative cosine, so positive cosine u, and then plus c, but holy goodness, what in the world did we say u was? U is the square root of x, so we're going to have the square root of x sine, goodness gracious, square root of x plus cosine square root of x plus c. And it looks like I just went and checked my answer and I lost my 2 here. That 2, let's see, that would have been down here because we did our uv. So all of that is times 2. I am sorry. I'm sure back up here y'all caught that mistake. But of course I didn't. Sorry, guys. All right, there's where the mysterious 2 went. I dropped my 2. Y'all do better than I do, please. And I will finish the rest of these in class tomorrow.